Hello everyone, thank you for the opportunity to present this. Hello everyone, thank you for the opportunity to present this paper. The paper entitled Graph-based process mining for measuring quality of business process model. And the author of the paper are Kelly Rosa Sungkono, Rian Nartosarno, Faradinda Mutia Kinanggit, I am Irsadani Dwi Subahi, and Kofifan Nur Laila. I'm Irsadani Dwi Subahi, one of the author of this paper, will represent a paper in this slide. So let's get started. There are 4 points that I will represent to this slide. First, introduction, and the second, method, and the third is experiment, and last but not least, conclusion. Process discovery is a rapidly emerging scientific field that focuses on the development of the theory and strategy for acquiring and conveying knowledge about real-world process execution and other organizational activity norms. In this process discovery approach, use event logs to automatically infer process model. That we look the case ID and the name activity, the date, time, and the date. Relationship in business process model has two types of basic relation. First is sequence relation and parallel relation. The sequence relation is link one activity and another activity. Meanwhile, parallel relation link one activity and other activity. There are three types of parallel relation. First, end relation, source relation, and or relation. The existing quality measurement research on business process model has a weaknesses. First, the process model must be changed to another process model to be able to calculate simplicity and generalization. And the second, it has not accommodate invisible tasks and non-free choice. In this graph-based quality measurement calculation are able to handle non-free choice and invisible tasks by modifying the cipher rule. In this figure, we show the graph-based process model lookup. The method of this research paper is first, we have the research method workflow, and second, discovering process model event log by study case that we use FP4, and the third is discovering process model code database by cipher rule query language use Neo4j tools, and last but not least, measuring quality of fitness, precision, generalization, and simplicity. In this research method workflow, the first step is to discover process model, and the second step is to measure its quality. By discovering process model event log, we use two study case. The first is waste handling study case, has 68 data records, and the port container handling study case has 165 data records. By this graph database in this figure, waste handling study case, we have a source relation, non-free choice relation, and sequence relation. And the next study case is port container handling, has source relation, sequence relation, non-free choice relation, and relation. After the process of the graph model is successfully discovered, the next step is to measure the quality of the graph process models. The quality measure consider are fitness that identify model can properly repeat the case record in the log is measured. The formula is total of captured traces divided by traces in event log. And the second is precision. Seeks to detect models that are overly generic and penalizes undesirable behavior. The formula is total of captured traces divided by trace in model. And the third is simplicity. It represents the complexity of a process model. And the formula is 1 minus hashtag DA, number of redundant activity, plus hashtag MO, number of operators not reflected in traces of the event log, divided by hashtag NO, number of operators. And the fourth is generalization that reveals how well it can support unexpected traces. The formula of generalization is 1 minus by sigma hashtag number until 1 and 4. Execution divided by hashtag number. Hashtag execution, it means number of operators executed in traces of the event log, and hashtag number, number of operators. The next slide is the example query for process. It to run and calculate simplicity quality measurement. And the first step is load the event logs. That event log have a log base and log model. The log base consists of all the column contained in the event logs, while log model only consists of the case ID, column, and the name of the activity. And the second step is discovering sequence relation node that build a sequence relation in the process model that connects the node with the next node. And the next step is counting relation that to calculate the number of relationships that exist in the graph model process. And the next step is discover sequence relations is used to see nodes that have sequence relation that exist in the graph model process. Instead of three parallel relation like OR relation, SOR relation, and relation. And the next step is counting many relations live from initial node and incoming relation to end node. That the first of the figure in this slide is calculate the number of relations that came out of the initial node that was successfully executed. And the second figure of Chiver rule in this slide is calculate the number of relations that enter the end node that has been successfully executed. And the next step is calculate simplicity with formula in graph process model. In the simplicity, the redundant activity calculate and can be seen on the similarity of activity names in the process model with different process ID. If there is no node that has an activity name with a similar equal to 100, then the value of the redundant activity is equal to 1. And the number of operator is calculated based on any relation that exists in the three process model in this formula. Based on the calculation results shown in table 1 and table 2, it's shown that the result of fitness and generalization for both methods are the same. The result of the generalization calculation between the two methods can be the same because both are calculated based on the three process model that was made previously as for the simplicity calculation results. Although both are also calculated based on the same process tree model, in the ETM quality measurement can detect invisible tasks, whereas graph-based quality measurement can detect them. The result of the calculation of precision for the two methods are different because trace of ETM quality measurement is seen based on the entire process model, while trace of graph-based quality measurement is based on each relationship that exists in the process model. The conclusion of this research is graph-based quality measurement, which are carried by graph-based quality measurement and ETM quality measurement, show different results in simplicity and precision. Different simplicity calculation result between the two methods is caused by the invisible task in the graph, and the different result in precision caused by the different calculation approach between the two methods. Thank you so much for your attention.